globally, how much is extreme heat costing our economy? And maybe even more critically, what's it doing to worker productivity?
Yeah, it's a huge question.
We've all heard about rising temperatures, obviously, but what does that actually mean for our wallets, and our ability to just get stuff done?
Exactly.
Today, we're going to dig into a really fascinating study. It zeroes in on Alexandria, Egypt, and specifically looks at the economic loss from occupational heat stress.
Right. We've got this detailed research paper here. It quantifies the impacts from 2000 right through to 2020, and it also gives us some future projections.
Okay.
So our mission for this deep dive is basically to unpack these findings, really understand the implications for productivity, for the economy, and maybe explore what steps, could actually be taken.
And just to give you a sense of the scale here.
Yeah, get this.
The paper found that in Alexandria, just between 2000 and 2020, extreme heat meant about 75% of the annual working days lost happened in the hot summer season.
75%. Wow.
Yeah. And that added up to an estimated economic hit of $8.1 billion US.
Billion. Just for Alexandria in that period.
Just for Alexandria.
Yeah.
It's a profound impact, really. And it shows just how tangled up climate change is with our, daily economic life. Places like Alexandria are already facing these deep systemic challenges.
That number really does put things into perspective. And when we talk about heat stress, it's more than just feeling uncomfortable, right? It's often linked to climate change, sure, but it directly cuts down physical work capacity, mental ability too, and it significantly bumps up the risk of accidents.
Okay. So actual physical and mental effect.
Exactly. And unlike, say, floods or droughts where you see this massive visible damage, heat stress is kind of insidious. It has these quiet impacts on health, on assets, on whole urban economies, and it hits vulnerable groups hardest: kids, the elderly, people with existing health issues.
So it's not just feeling warm. It fundamentally impacts performance.
Yeah.
And the global economic side of this is, well, it's staggering. We've seen studies showing productivity goes up with temperature to a point, maybe around 13 degrees C.
Right, there's an optimal point.
But then it just falls off a cliff. And that's not theoretical. It's actually being measured.
Precisely. And globally, the cost just from lost productivity due to climate change, it's projected somewhere between 0.31% and 2.6% of global GDP by 2100.
That's a huge range. But even the low end is massive.
It is. And one study projected that under a high emission scenario, they call it RCP 8.5, basically business as usual warming.
Okay.
By 2100, just the heat-induced productivity slump could mean an average drop of 1.4% in global GDP compared to, a world without climate change.
And the timeline on some of this is, well, it's worrying. The International Labor Organization, the ILO, back in 2019, they projected that heat stress, even under a optimistic scenario, could cut total working hours worldwide by 2.2% and global GDP by something like $2.4 trillion US by 2030.
By 2030. That's basically now.
It's just around the corner. What's driving these huge global impacts? Is it mainly outdoor work or?
It's a mix, but yeah, vulnerability is key, especially in regions with lots of outdoor labor or, less developed infrastructure to cope. Look at the U.S., for example. The cost there was estimated around $465 million.
Okay.
But that's projected to triple under that high emissions RCP 8.5 scenario by the end of the century.
Wow.
But for developing regions, the projections under RCP 8.5 by 2100 are even worse. India could see a GDP hit up to minus 32%.
32?
Yeah. Brazil, minus 7%. Africa, nearly minus 5%. The Middle East, also around minus 5%.
Yeah.
What's really interesting is how much it varies, depends on the economy's structure.
Right.
And it often gets amplified in cities just because you have so many people and so much economic activity packed together.
Which brings us right back to Alexandria, Egypt, the focus for this deep dive. You said it's a critical case study.
Absolutely. It's critical because it hosts something like 40% of Egypt's entire industrial production. It's the main port.
So a real economic engine for the country.
Definitely. It's a major hub. Population of 5.5 million now. Labor force back in 2020 was nearly 1.5 million people. That's about 6% of Egypt's total workforce.
Okay. And how does that workforce break down?
Well, services make up the bulk, about 64.5%. But manufacturing, construction, agriculture, those combined are about 35.5%.
So more than a third of the workforce is in sectors often involving outdoor or physically demanding work.
Exactly. Highly exposed to heat stress. It makes Alexandria a kind of perfect laboratory to study these effects closely.
And this specific regional focus, it sounds pretty unique.
It is, yeah. The authors mentioned that, as far as they know, this hadn't really been looked at in depth for North Africa, especially Egypt. There was an older global study, but it gave a much broader, less detailed estimate for Egypt back in 95, projecting out to 2030.
Right.
So this new research gives us a much more granular and up-to-date picture.
Okay, so how do they actually go about quantifying this? It sounds tricky.
It is tricky. They use something called the Wet Bulb Globe Temperature Index, WBGT.
WBGT.
Okay. It's pretty commonly used to measure heat stress. It doesn't just look at air temperature. It factors in humidity, wind speed, radiant heat.
Ah, so it's more about how the heat actually feels to the body.
Precisely. It gives a much truer picture of the physiological stress. They chose that over some more complex indices that just need way too much data for this kind of historical look back.
Makes sense.
Then they gathered historical weather data for Alexandria, 2000 to 2020, plus labor force numbers, GDP per capita data.
Okay, so they got the weather data, the economic data, the labor data,
Yeah.
and then they crunched the numbers.
Pretty much. They analyzed the temperature and humidity patterns, used the WBGT index and the workforce numbers to estimate daily productivity losses, and then they added all that up into annual losses.
And put a dollar value on it using GDP per capita.
Exactly.
It sounds thorough, but like you said, it's complex.
Yeah.
How accurate can we really be when measuring something like lost productivity from heat? Are there big assumptions in these models?
That's a really fair question. And yeah, the study acknowledges these challenges. No model's perfect, right?
Sure.
But by using established tools like WBGT, which are standard in occupational health, and by using 2 decades of solid data, they can create a strong, quantifiable estimate of the direct economic hit. The aim isn't necessarily pinpoint precision down to the last dollar.
Right.
It's about providing a robust enough estimate to actually inform policy, to drive action. And their findings for Alexandria, they're pretty stark.
Especially the warming trends.
Let's get into those key findings then. From 2000 to 2020, you said it's clearly getting warmer.
Definitely. Monthly mean temps range from about 14 degrees C up to nearly 30 degrees C, peaking in August.
Okay.
And over those 20 years, the hot summer seasons, June to September, and humidity was high too, like 82% on average.
Very. And the study found a statistically significant upward trend in the annual average, the maximum and the minimum temperatures.
So across the board.
Yeah, a clear warming climate. Humidity went up a tiny bit, but that wasn't statistically significant, though it did become more variable. So yeah, it's not just a few random hot days, it's a systemic shift happening.
And the price tag for the lost work that came with that shift.
Substantial. The analysis showed a big loss in productivity, and like you mentioned earlier, it was really concentrated in that summer season, June to September. That period accounted for almost 73% of all the lost working days.
Okay, and the total number of lost days over the 20 years.
Get this. 438.9 million working days lost in Alexandria alone.
440 million work days. That's hard to even picture. That 75% figure for summer losses really hits home. It's not just money. It feels like it would disrupt the whole city's rhythm.
It absolutely would. A massive disruption to life and progress.
So the sheer volume is huge. But what about how it affected different parts of the economy? Did the study break that down?
It did, and that's really insightful. The impact varied a lot between sectors.
Okay.
So the annual average loss in the office and services sector was about 29 days per worker per year. Construction and agriculture lost around 70 days.
More than double.
Yeah, but then manufacturing. They saw an average of 196 lost days annually per worker.
Wow, almost 200 days. Why is such a huge difference there compared to, say, services?
It's a mix of exposure and sensitivity, you know?
Yeah.
About 3/4 of the total lost days came from office services and agriculture construction combined.
Right.
The office sector, maybe less direct outdoor heat, but it's very sensitive. Even moderate heat affects concentration, mental tasks.
Okay, cognitive impact.
Exactly. Then agriculture and construction, huge exposure, right? Outdoors, physical labor. And they have less elasticity, less flexibility to just shift work times easily. Manufacturing often involves indoor heat from machinery plus ambient heat and maybe less flexible schedules too.
Got it. And this all added up to that $8.1 billion hit to Alexandria's economy over the 20 years.
That's the estimate, yeah. The office and services sector actually bore the biggest single chunk of that, cost about $3.7 billion, or 46.6%.
Even though they lost fewer days per worker than manufacturing.
Right, primarily because that sector is just so big. It's nearly 65% of the total labor force. Volume matters.
Okay.
Construction and agriculture faced losses of about $2.45 billion. That's around 30.5%. They're a smaller slice of the workforce, only 17%, but their higher exposure and lower flexibility made them really vulnerable, hitting them hard proportionally.
And this is a really crucial point you flagged earlier. These numbers only cover the formal economy.
Exactly. The study points out that the informal sector in Egypt employs something like 64% of the total workforce.
64%.
Yeah. So the true scale of these losses, it's almost certainly much, much higher than that 8.1 billion figure.
That's a massive blind spot. It means the problem is even bigger than these already huge numbers suggest. Okay, so what about looking ahead? Is it just going to get worse?
Well, the projections aren't great, frankly. Alexandria is expected to see even more frequent hot days, which they defined as over 30 degrees.
Okay.
Compared to a baseline period, 1995-2014, which had about 90 such hot days per year on average.
Right.
Projections for 2040-2059 show that jumping to 125 days under a moderate emissions scenario, SSP1 2.6.
That's roughly a 40% increase.
Yep. And under the high emissions scenario, SSP5 8.5.
The business as usual one.
Right. That goes up to 140 hot days, a 55% increase.
Okay, so quite a bit hotter sooner. What about further out?
Further out, say 2080, 2099.
Yeah.
Under the moderate scenario, it stabilizes around 140 days, but under that high emissions path, it climbs to 182 hot days per year.
182 days. That's half the year being classified as hot.
Pretty much. And you combine that increase in hot days with, growing populations, growing economies. It's just going to amplify these economic losses unless serious adaptation happens.
Right. The urgency seems undeniable, which brings us to adaptation. What can actually be done? The findings clearly show we need a proactive approach, right?
Absolutely. Proactive and multifaceted. The good news is there are options. They range from what the study calls low-regret actions.
Meaning things that make sense anyway.
Exactly. Things like improving basic ventilation, stuff that's beneficial regardless of how much it warms, all the way up to more expensive solutions. And these can happen at the company level or the policy level.
Okay, like what? Give us some examples.
Well, thinking about infrastructure and urban planning, you could improve work environments with better ventilation, adding shade, using reflective or insulating materials on buildings, on equipment.
Practical stuff.
Yeah. And thinking bigger picture, urban planning could integrate heat mitigation, more green spaces for shade, and cooling evaporation, trying to lower the whole city's temperature a bit.
Makes sense, like tackling the urban heat island effect.
Exactly. Then there are technological fixes or workplace adjustments, things like air conditioning where feasible, maybe misting systems.
More direct cooling.
Right. And the study also stressed the need for sector-specific actions. You can't have a one-size-fits-all solution.
Okay, so tailored approaches. What would that look like for, say, manufacturing versus agriculture?
Good question. For manufacturing, maybe better ventilation in factories, ensuring workers have easy access to water, adjusting work schedules to avoid the peak heat, proper heat protection protocols.
Right.
For agriculture, maybe flexible schedules are key, especially for tasks that aren't strictly time-bound. Let workers avoid the absolute hottest poles of the day.
It's clear that really understanding the vulnerabilities sector by sector is crucial for making any mitigation effective.
That's absolutely right.
So what we've really seen today is that heat stress isn't some, abstract climate change thing off in the future.
No, it's here now.
It's a concrete multi-billion-dollar drain on economies right now. It directly hits the productivity, the well-being of millions of workers. And this Alexandria study just drives that home so powerfully.
It really does. And it raises a pretty important question, I think, for you listening. Beyond these direct economic losses, the lost productivity we've talked about, what are the ripple effects of this increasing heat stress across society? Think about public health, the added burden on healthcare systems. Think about social equity. How does this disproportionately hammer people in tough physical jobs, or maybe in the informal sector who have almost no safety net?
Yeah, the equity dimension is huge.
It is. And maybe also think about what new challenges, but also what new innovations might actually emerge because we're being forced to adapt to this.